closer than you think.
We're already well past the point where people's imagination are making it difficult for them to tell the difference between reality and the virtual space they're in.
At Electronic Arts, the masterminds behind the wildly popular Sims games created an entire alternate reality, a way to play out virtual lives in virtual environments designed by the user.
SimCity in many ways is more of a toy than a game. And we like that characterization because toys often feel far more flexible in terms of how you can interact with them.
It takes the responsibility of the content and puts it in the player's hands. And that's incredibly powerful. If you describe it to people, it doesn't really sound like fun. It's like, hey, how would you like to manage the civic problems of a city?
The popularity of these interactive simulation games reveals a fundamental human need: to play.
I think we play games from a biological imperative to safely and experimentally work out situations where the stakes are lower.
Because virtual games let us live in a risk-free world, they will be used for more than just entertainment. Security officers will use gaming technology to run emergency scenarios, testing response times. Pilots will train under ultra-realistic circumstances, with no risk to the aircraft or themselves.
We'll be spending, in fact, most of our time in these virtual environments because they'll be just as realistic as real reality, but a lot more exciting.
Be able to touch, smell, and feel things happening thousands of miles away.
The sensation is really extraordinary. I don't know if you're getting a sense of it. That movement there, that's my finger moving down on this object. Now obviously this object isn't really in front of me, it's on the screen. But I can feel it. As I move my fingers around, I can feel that texture. It's extraordinary. I'll just show you actually what's happening inside. If I can just open it. Can you bring the camera in there? Those tiny little pins there, they're feeding back to my finger the shape of that virtual object. In fact, if you look on my finger, you can see that. The indentation that they've caused. The possibilities for the military, for medicine, even video games are mind-boggling.
This is the Pebbles robot, and according to its makers, Telbotics, it's the world's first fully functioning telepresence application. It allows sick children in hospital to still attend school classes. They're linked to the classroom via two-way video and audio links, and the robot is kitted out with a scanner and printer so that essays can be handed in and homework set. Pebbles even means the student using it can put their hand up in class.
And telepresence technology has been used in medicine for a while now.
The first major transatlantic surgery was a telerobotic gallbladder operation performed by surgeons in New York on a patient in France 4 years ago. In the States, they've developed a telepresence armed response unit called TRAP2. This allows police officers to
In this part of the series, Immersive Tech presents haptic devices. Technology today has provided people with the ability to experience movies in immersive environments by providing sensations through 3D goggles, glasses, and even smell, such as the cell phone and laptop devices developed by NTT Communications. But what about kinesthetic and tactile senses like touch and feel? This is where the field of haptics come into play. What are haptic devices? Haptics is commonly referred to as the ability to interact with a virtual environment through physical contact, such as receiving sensations associated with what is going on in the virtual world through touch. There are two types of feedback, tactile and kinesthetic. Tactile feedback involves the sensation of touching an object, while kinesthetic feedback involves the dynamic feelings associated with the movement of something as shown here by the robot hitting the sponge in Japan's Onishi laboratory. Haptics works through linking a part of the human body, usually the hand, with an interface. When the hand moves, the sensors that are connected send signals to a computer that then calculates the kind of response given back, such as hard or soft, depending on the virtual object. The first major breakthrough in haptics technology came in 1993 when MIT's AI laboratory created a device that made it possible for a person to feel a virtual object. Since then, haptics technology has been making their appearance in everyday products such as smartphones that vibrate when touched. Haptic devices are even being merged with other fields of immersive technology. Researchers at the University of Tokyo have managed to combine haptics with augmented reality with the creation of a hologram that can be paired with a tactile feedback system to give the user a physical feeling of the holographic object. What's more amazing is that it requires no special equipment, just your bare hands. Imagine whole industries in the future that can bring consumers virtual projections of anything they want and are not only able to see it, but physically interact with it as well. Yet in order for the future to arrive, scientists and developers must make advances in the hardware of haptic interfaces in order to more efficiently compute the massive and complex data sets required to give accurate real-time feedback as demonstrated by this haptics table developed by the University of Calgary. Immersive tech sees great potential of haptics in areas of entertainment and the arts, education, and health. Sculptors will be able to craft their art on a virtual canvas with the realism on an actual physical object, such as the DAB system developed by UNC Chapel Hill. For those who have lost their eyesight, Seeing Aid is developing a haptic glove that allows the blind to experience wonders like our national parks by using it to mimic the feel of environments. Students will someday perform dissections using virtual specimens that provide for a more sanitary and cost-effective way to learn. Haptics can also bring to the classroom things that you cannot touch for real, such as the feel of exotic animals or objects ranging from the size of atoms to planets. One day, doctors and medical students will be able to get an accurate idea of the texture of an organ before they handle the real thing. This will allow for doctors in the future to perform procedures such as surgeries and mammograms without even needing to be next to the patient. Haptics will one day be applied to robotics to create machines that can explore uncharted or dangerous territory and give its controllers the ability to safely interact with the unknown through the use of a force feedback system. As technology progresses to stimulate our visual senses, so too will we see an advancement in touch. Haptics will bring new possibilities to learn, entertain, and live better, and will soon become an integral way of how we experience the world around us.
We're creating this device for stroke patients with motor disabilities. We combine 3D technology, virtual reality, motion capture, and brain activity measurement in real time into a simple, easy-to-use box. So for example, when the patient moves his arm, he can watch himself in the virtual world on an avatar with the movements being mapped in real time. At the same time, all of this data is available to the doctor online in real time. So making this whole process independent, but with objective measurement, and also at the same time simple to use. So we're creating a simple, easy to use home rehabilitation product, and that's the goal. Around the world, every 45 seconds there's an occurrence of stroke, and every 3 minutes there's a stroke-related death. So this is a serious problem. Around 12.5 million patients each year have a stroke, and 75 to 80% of these patients have upper limb movement disabilities. And current solutions have complicated architectures, they're very expensive, and have monotonous routines. So patients don't see progress, and because of the lack of motivation, they quit the process. So there's a very strong need for a solution that's simple and portable, so these patients can take it home and make it more efficient. Being a medical product, we're currently in the stage of finishing up our preclinical trials.
Stanford University.
Adam is going to see a virtual world that we've built, but it's going to be projected in 3D. So he's going to wear what's called an HMD, which is a head-mounted display.
That's okay. That's good.
Also, they'll be getting touch feedback as well, so we use what's called a haptic device. It's a setting that is in a forest, so you'll see trees and hear birds. But the task that's involved is to cut down a virtual tree. Virtual reality is great because we can immerse people in situations we wouldn't be able to normally test in a lab. The point of the tree study is to look at how different levels of immersion in a virtual world, do those types of immersion in a virtual world carry back into the physical world. And there it goes.
It was kind of strange, cutting something down that wasn't there.
What we found was that only the people that were immersed in virtual reality were the ones that actually changed their behavior. So they were the only ones that actually chose to conserve more paper.
Branches are crashed and scattered out on the ground. The top of the tree is just lying straight out in the field.
So cutting down the virtual tree actually started to make them think about their behaviors a little bit more. So maybe they would start to think about their impact on the environment, and maybe start to think about products as well. So maybe I would choose to pick a product that was maybe recycled as opposed to non-recycled. And that was based on, just being immersed in this virtual experience.
Good afternoon, Miss.
Good afternoon.
Yeah, so I would like to interview for this IT project that I'm doing, and which is about the psychodynamic effects of virtual reality onto people's mind. Now, I would like to start by you talking about the psychodynamics. What exactly is psychology and psychodynamics?
Okay. When we're talking of psychology, we are looking at how whatever is happening in our environment has an impact on us, and virtual reality is also a part of that environment. So when we look at virtual reality and we look at all the aspects of it, the impact on the person who is at the receiving end is what is the psychodynamic impact of virtual reality. It's based on the principle or the theory put forth by Bandura, which is the social learning theory, now the social cognitive theory. It talks about how we observe whatever is happening in our environment and we learn from that, and how children particularly are very impressionable and they are more likely to get a lot out of it only through observation. So if we are looking at taking the social learning theory in the outside world or in the outside environment, we are looking at the impact of virtual reality or the games that children play, and the impact it can have on their understanding of the world, and more likely to observe aggression. And if the virtual reality or the games or the interface, if it has content which is aggressive in nature, then children are likely to develop scripts based on what they see in the virtual world, and that can have an impact on what they feel is actually the real world. So for children, it's becoming difficult, maybe if they are exposed to virtual reality for a prolonged period of time, to differentiate between what is real and what is not real. The virtual reality can actually give them ideas as to how the world is, how it could be interpreted by them as being much more hostile. It can actually give them ways as to how to be more aggressive, learn new ways of aggressing. So it needs to be very much monitored, so to say, because otherwise it can have a negative impact on children. Also for adults, what happens is that whatever experiences that we have, they kind of help us in making scripts or schemas, so to say, of those events. And the more the individual is involved in those activities virtually, and then if the same activity is to be done in the real world, there is a lot of overlap, and that can have an impact in terms of becoming difficult for the individual to draw the boundary that this is the virtual world and this is the real world.
Okay.
So it's like that.
Okay. Thank you so much.